So first thing first, we need to understand what trig ratios are. For you to understand trig, you need to understand the trig ratios. And what I mean by that is that you need to understand how sine theta, cos theta, tan theta works. And in the context of SOH CAH TOA, this video is going to talk about that. I hope you guys are ready. So what is SOH CAH TOA? Where the S represents sine, the C represents cos, the T represents tan, the O represents opposite, the A represents adjacent, and the H represents the hypotenuse. So now let's see how each and every one of these moving parts fits together to form SOH CAH TOA. Now, SOH CAH TOA is normally used for right angle triangle. That's one thing you need to always remember. It helps you find trig ratios. So yeah, when you have a right angle triangle, the side that faces your angle is normally referred to as the opposite. We have the side that faces the 90 degrees is called your hypotenuse. And finally, the third angle is called your adjacent. And that's exactly what each and every one of this represents. So what this means for sine, which is the sole part of your SOH CAH TOA, is that your sine theta can be represented as opposite over hypotenuse. So that's your SOH. The cat part is your cos. So it is cos theta can be represented as adjacent over hypotenuse. And finally, the TOA part can be represented as opposite over adjacent. And you always use these trig ratios to find the values of angles, the values of a side, whenever you have a right angle triangle. Now, if you have two sides and you're missing one particular side, you could use Pythagoras to calculate that side. And the formula is the hypotenuse square is equals to the addition of the other two side squares, which is the opposite and your adjacent. And this is kind of like a brief explanation of how SOH CAH TOA is used. Now that you understand how SOH CAH TOA works, let us do a quick example for you to get a better understanding of how to find sides, angles using SOH CAH TOA. A quick example of SOH CAH TOA here is we have our opposite to be 4, we have our adjacent to be 3, but we see here that our hypotenuse is unknown. So like we talked about using Pythagoras whenever you have a right angle triangle, we would say that our hypotenuse is equals to this. The length of your hypotenuse can be written as 5. So if we are trying to get our sine theta, our cos theta, and our tan theta, all we just need to do for each and every one of this is substitute. So for sine, since we said it is the sole part, so let's write this one more time. The sine is opposite over adjacent. So this means that this is 4 over 5 because that's opposite to your angle. Cos would be adjacent over hypotenuse, which makes it 3 over 5. And finally, your tan theta would be opposite over adjacent, which would make this 4 over 3. This is a brief example of how you can use SOH CAH TOA in a proper right angle triangle. And with all this, I hope you understand SOH CAH TOA a little bit better. Now with SOH CAH TOA at the back of your mind, what happens if you're not given a proper right angle triangle? How exactly do you answer a question? What if you're given a point on a Cartesian plane? What exactly do you do? Now there's another way you can find your trig ratios without saying opposite, adjacent, and hypotenuse. We still use it to inform our choice. This section explains exactly what I'm trying to say. Another format for trig ratios normally happens in a Cartesian plane. So if you're given a point, and this point, let's call it x and y, we understand that the distance from the origin to the point would be represented as r. All we need to do is draw a line connecting the x-axis. And what that does is that it creates a right angle triangle. That will mean that this is a right angle triangle. This is your distance for your y, and that's your distance for your x. Now, it doesn't necessarily have to be drawn in here. If your x and y, let's say you have a negative x and a positive y, you would have it drawn in this quadrant, looking like this. And the same thing would also apply. So in this case, your x will be negative x, your y will be positive y, and you have your r here. If you do have one unknown, either your y, your r, or your x, we normally say we use Pythagoras also, which looks like this. And for each and every one of them, your sine theta is represented as y over r, your cos theta is represented as x over r, and finally, your tan theta can be written as y over x. Now, it's very important you know these trig ratios in answering questions. With y, x, and r at the back of your mind in answering trig ratios, let us do an example to help you put all this into perspective. So take, for instance, you have a question which says, we want to find sine theta, cos theta, and tan theta of points -5 and 12. So let's draw our Cartesian plane to start with. We understand that -5 is on your negative x side, positive 12 is on your positive y side. So let's draw, okay, let's first of all put the point. So we can put it like -5 and 12. So let's say that's the point. So we draw that. We connect a line with that to the origin, and that gives you your r. We're going to call that our r, or radius. So like we said, we draw a line connecting the y-axis down. So when we draw this, we understand that the y is 12 and the x is -5. Now you notice that we do not have the r. So to get the r, we use Pythagoras, which is r squared is equals to x squared plus y squared. So r squared is equals to . So now it means our r is 13. Now to get our sine theta, we understand sine theta is y over r. So in this case it would be, to get our cos theta, you understand cos theta is x over r. So in this case it would be. And finally, to get our tan theta, you understand tan theta is y over x, and in this case it would be. And this is exactly how you use trig ratios in a Cartesian plane. And that's it. This is an important pillar of trig. You understanding the concept of trig ratios, because every single section we're going to talk about is going to be based on this. So if you do understand this, you would have an easier time going through the next section. So now we're going to be talking about special angles next. For more videos on trigonometry and other sections in mathematics, please check out the description. And on your way out, please don't forget to like and subscribe. Thank you.